Okay, so we have a problem that'll be on the test that might look something like this. Might not be an exact form, but it's going to be a form similar to this. You're going to have to do something very similar. And it's written out like this. Then you know to plug in your numbers for A, B, and C. My numbers are 5, 4, and 6. So I plug those numbers in for A, B, and C. And now it looks like this, right? Okay? And then people have a problem. People are going to want to subtract that 4 from that 6 because it's the first thing their eye catches. That's not what you do. Order of operations says division goes before subtraction, so it's got to be x divided by 6, which you write like this, minus 4. Not x over 6 minus 4. That's what you would have if these were in parentheses. X is divided by 6, then you subtract 4 from the result. There's no minus 4 in the denominator, even though some textbooks will actually write it that way. Okay, there's this thing called implied division. And it's ridiculous because people have a hard time understanding the rules. Why bend the rules when you can just insist on doing things mathematically correctly? One way, order of operations. Okay, so anyhow, it's not this. Meaning it's not x over 2. It's this. Okay, so we do that. Now, how do we solve this? The words that nobody seemed to want to repeat, although I'm sure everybody knew them. We have denominators, so we multiply by a common denominator. Now, the suggestion I got was a good one, multiply by x plus 5. And apparently there's some thing on the internet out there that tells you to do that, but not to multiply by the 6. You know, somebody needs to take that site down. Either that or tell me why I'm wrong. Okay, lots of luck with that. You can't convince an old man of anything. Okay, now, okay, we have this, right? So we multiply by x plus 5 times 6 times 4 over x plus 5 equals x plus 5 times 6 times x over 6 minus 4. We multiply both sides by the same thing. This gives us this. Now you're going to want to draw lines through things. I don't permit that. I don't accept it. I always penalize it from now on. Unless you tell me why you drew those lines. Again, because 70% of students, and even at the end of a pre-calculus class, will cancel incorrectly because they don't understand the reasons, because they never had to understand the reasons in the prerequisite courses, and we don't have time to teach you Algebra 1. Okay? So I don't allow it. I've stressed that before. Well, actually, I'm skipping a step here. I don't want to do that. I've already got the minus there. Okay? So that's what it looks like. Now over here, 6 times 4 is 24. And this is just what you'd have if you multiplied x plus 5 over x plus 5 times 24, isn't it? I mean, if I multiply x plus 5 over x plus 5 by 24, I get x plus 5 times 24 in the numerator, which matches this numerator. And I have x plus 5 in the denominator, which matches this denominator. So this certainly equals this. So you can see why this equals this. And this equals x plus 5 times 6 times x over 6. And this equals x plus 5 times 24. Now I'm going through a lot of steps here, but by skipping those steps, too many people will make a mistake and will fail to learn the algebra they would have learned if our prerequisite courses did what they are supposed to do for people of your ability. Okay? And you have good ability. Everybody. Okay, well, x plus 5 over x plus 5 is 1. And then this can be written as 6 over 6 times x plus 5 times x. I didn't need to put that as a numerator. Okay? And this is just minus 24x. And I'm going to do this, plus 120. I'm not going to try to distribute the negative sign at the same time I distribute multiplication by 24, because I'll tend to write minus 24x plus 120 or something. Okay? And this is 24, and this is 1 times this, so I'm going to skip a couple of steps here since I've illustrated it already. That's x squared plus 5x minus 24x plus 120. Then the 5x minus 24x is negative 19x. So I'm going to do it slowly. I could combine these things, but I'm going to say x squared minus 19x plus 120. And now I subtract 24 from both sides, and I get x squared minus 19x plus 96 equals 0. That's the rigorous algebra. You should be able to do that. If you don't do that, make sure everything's valid, because I will penalize invalid steps. I'll still give you credit for knowing the overview of how to do the problem, depending how bad the algebra errors are. I'll give you credit for what I can, but you got to get the algebra correct to get full credit. Then you solve this equation. How do you solve this equation? First you say, aha, with a couple of exclamation points. That's optional, but that indicates that you've looked at the equation and figured out that it's what kind of equation?
Quadratic.
Yeah. A equals 1, B equals negative 19, C equals 96, so that x equals negative of negative 19, plus or minus the square root of negative 19 squared minus 4 times 1 times 96. Of course, you can see that's going to end up negative, so you're going to not have any solutions, not any real solutions. But actually, no. Yeah, no, yeah. It's almost not negative. Okay, this is 361 minus 392 over 2. That's going to be the square root, and check my arithmetic, but you're going to get a square root of negative 31 over 2. No real zeros. What else can you tell me? That I would like to see but isn't required if all I'm asking you to do is solve the equation. Yeah, I would also note The axis of symmetry is where x equals 19 halves. Right there's your axis of symmetry. So even though you don't have zeros, the axis of symmetry is still halfway between them. So I do recommend you practice such things. There's another form of an equation that comes up. How would you solve that equation? Well, if a number squared is 6, what can you tell me about that number? Well, let's make it a little easier so you don't have to think too hard. Let's say it's 36. What can you tell me? What would you square to get 36?
The absolute value of 6.
I'm sorry?
The absolute value of 6.
Good thinking, not quite the right statement, because the absolute value of 6 is 6. But any x whose absolute value is 6. Okay? So you have the right idea. Okay? This tells us that the absolute value of x minus 4 equals square root of 36, so that x minus 4 equals the square root of 36, or x minus 4 equals negative square root of 36. So, that square root of 36 is easy. Something's wrong. This is x equals 10. Okay? Then you check it. It's something that I don't see a lot of. It's especially important on tests, because you can save yourself points by checking. Among other things, if you've made a simple error and it's wrong and you check it and find that it's wrong, I'll penalize that simple error less. Okay? Plug 10 in. What's 10 minus 4? 6. You square that, you get 36. Plug in negative 2. What's negative 2 minus 4?
-6.
It's negative 6. What do you get when you square negative 6? You get 36. Okay? Now, you could also I'd really like to see this, because it reinforces something that people screw up in this course all the time. In my sections, in the dual enrollment sections, and other people's sections. Don't know why, because it's really pretty simple, but it happens. Maybe we just don't spend enough time on it or assign enough problems. I don't know, it might be our fault. Alternatively, anyhow, you say x minus 4 squared equals 36. So what do you square to get 36? It's either going to be 6 or negative 6. And if this was 37, you don't know what the square root of 37 is, but you know it's either going to be the square root of 37 or negative square root of 37, right? Okay? So, that means it's either plus or minus this, so you have one equation for the minus, one equation for the plus. They're the same equations we had here, so the solution proceeds the same way it did previously. Make sense? So the two big things I'm kind of testing here is, do you know what to do when you got denominators? Do you know what you do when you have a quantity squared equal to something? And then there's a third thing. How about x to the 5 over 4 equals 6? How do you solve that one?
Take the fourth root of the fifth power of x.
That's true. But that's not the easy way to solve it. Okay? Okay, there's going to be one of these. Okay? We've illustrated it before. We've done this a few times. What's x to the 5/4 raised to the 4/5? What do your laws of exponents tell you about x raised to a power and that raised to a power?
X to the first power.
The what?
X to the first power. It'd be x
No,
to
it
the
doesn't tell you
24,
x is to
20.
the first power. It tells you multiply the powers. Of course, when you multiply those powers, it is the first power, but you didn't answer my question. You skipped ahead and answered the next question, which is still pretty good. Okay. That was good. Okay, so we can write this. Why does that work? Because of the laws of exponents. The 4/5 power of x to the 5/4 is x to the 5/4 times 4/5. That's 6 to the 4/5. Okay? Now what's 6 to the 4/5? Probably 5 point something. Okay? You wouldn't know. Unless you happen to graph the x to the 4/5 function. But that would be challenging in itself. Okay? And make an estimate, you could come pretty close. But you don't know, that's something you would go to your calculator to approximate. But if you get this, I know you can put 6 raised to the quantity 4/5 into your calculator. So, accept that answer. Okay? So you want to tell me what it is approximately? I can't approximate it very closely without thinking a little more. Okay? So I don't expect you to approximate it. Make sense? These are all techniques that we've done. They're all exercises and laws of exponents and rules for solving equations. Okay? So, you know those things and understand the principle behind them, you'll be okay.